So we are going to continue with our physics today, and we are going to be looking at the measurement of the three basic fundamental quantities that we have. Now we have a lot of fundamental quantities, as you have discussed before. We said we have 7 of them. So today we are going to be looking at how we can measure these fundamental quantities, but basically we are going to be talking of measurement of just 3 of them. Now, so how do we measure length dependent quantities? How do you measure length dependent quantities? No, we have talked about the measurement of length before. We said we can measure length with the vernier caliper, we can measure it with the meter rule, we can measure it with the micrometer screw gauge, depending on the kind of situation that you are having. That's going to determine which one of them you are going to be using. So, but today we want to look at, since we have discussed that, we want to look at how we can measure even those quantities that depend on length. So, for example, we have volume. How do you determine the volume? Now, the volume of an object can be determined based on the shape of the object. Now, we have objects that are regular, and we have objects that are irregular. So those regular objects are objects that they have a kind of fixed dimension. There's a very easy way to know their dimensions. You can easily measure their dimensions and use that to get whatever you want to get. But for irregular objects, you can't do that, because basically an irregular object cannot be splitted into known shapes, but irregular objects can be splitted into known shapes. A good example of a regular object is a cylinder. This is a cylinder. It is a regular object. Why? Because I can split it into known shapes. There is a circle on top. There is a rectangle below it. Then on the base there is also a circle. So this is a regular object because I can split it into shapes that I know their properties. But for an irregular object, you can't do that. Example of an irregular object is maybe a stone. You have a stone. How do you want to split a stone into known shapes? It is never possible. So you can't do that for irregular objects. So an example of a regular object is a rectangular block. An example of a regular object is a rectangular block. So let me try to draw that. So we have something like this. This is a rectangular block. There is a rectangle on top. There's another rectangle by the side. So it's looking like a cuboid. Then there's another rectangle. Then if you try to finish this, we have something like this. So this is how a rectangular block looks. Now if you look at it, it has different dimensions. There is the length, there is the breadth, and there is the height. That the height is like how tall it is. So this is the height. Now it doesn't matter, the orientation of the body does not matter. The orientation does not matter. Just maybe you can change it anyhow. You can come and put the length, you can come and put it here, put the breadth, put it here. It doesn't matter. Just put it anyhow, but make sure from the base to the top you use that as the height. I didn't mean that I had drawn it this way. If I had drawn it this way, so in this case, what am I going to say? I'm going to say this is the height, which is how tall it is from the ground. So this will be the height. This is going to be the length, and this is going to be the breadth. Now look at it. So that means that the length and breadth always come from the side that is on the ground. So this is the ground level. So look at the length, which is the longer side, and the breadth is the shorter side. You are going to see that it corresponds to what we did here also. The side that is placed on the ground, that's why we chose our length and breadth. The longer one being the length and the shorter one being the breadth. Why the height is just the distance between the part that is on the ground and the part that is on top. So this is how we have a rectangle. Now, a rectangle is an example of a prism. You are going to do this later in mathematics, but whenever you want to find the volume of a prism in math, the volume. Now, volume of a prism is just a shape that has the same cross section. What I mean by the same cross section is the shape that you are having on top is still the same as the shape that you are having below. If you look at this, on top we are having a rectangle, and below we also have a rectangle. So a rectangle is an example of a prism. Another example of a prism is a cylinder. Why is a cylinder a prism? On top you are having a circle, below you are also having a circle. We also have different examples. You can have a triangular prism, a prism that looks like this. On top you are having a triangle, and below you are also having a triangle. A cube is also an example of a prism. This is a cube. It's an example of a prism. Why? Because on top you are having a square, and below it you are also having a square. This is another square. So those are prisms. Now in maths, how do you find the volume of a prism? How do you find the volume of a prism in mathematics? The volume of the prism is just the area of the base multiplied by the height. This is how we find the volume of any prism. So since a cuboid, which is a rectangular block, is also a prism, then we can use the same way to find the volume. So what's the area of the base? No, the base here is actually a rectangle. And what's the area of rectangle? Area of rectangle is just the breadth multiplied by the length, or the length multiplied by the breadth. So we have length times breadth multiplied by then the height. So this is the height. So you just multiply it with the height. So that's how we got LBH. So this is how we calculate the volume of a rectangular block. And it's very easy for us to get, because we just need to measure this, measure the breadth, use a meter rule to measure the breadth, use a meter rule to measure the length, use a meter rule to measure the height. Now in these cases, you can use micrometer, screw gauge, or vernier caliper, because the object is quite big. You only use those ones when you are measuring small dimensions. Now, so if you are having an irregular solid, if you're having an irregular solid, it's very easy for us to measure the volume. We are not going to take the volume of the object directly. What we are going to do is what? We use a measuring cylinder to determine the volume of water it displaces, and that is going to be equal to its own volume. So that's how we do it. We are going to use a measuring cylinder. And how do we go about that? We just look for a measuring cylinder. Now the cylinder is going to be graduated. Then we pour water inside the cylinder. So let me use something else for water. So we pour water inside the cylinder, and we note the level of the water. So at this point, we just read it. You look at it here, and we note the reading. Let's say the amount of water here now is just 10 cm cube. That's the value that we got from here. So what we now do is that we are going to take our irregular object. Let's say this is the irregular object. Then we put it inside this water. Now after you put it in the water, we are going to have something of this nature. We have this. We have the graduation. Then we have our irregular object in the water. Now what do you notice? You notice that the level of water has gone up, right? The level of water has gone up. This was the previous level of water. Now see the new level of water. So what we are going to do is we are going to read the new value. So we look at it again and take the new value. So if you notice, maybe the new value is like maybe 15 cm cube. Now what will now be the volume of the object? Now the volume of our object will now be the final volume minus the initial volume. That's the volume before, that's the volume after we threw the regular object into it, minus the volume before we put in the irregular object. So this will be 15 cm cube minus 10 cm cube. So this is going to give us 5 cm cube as the volume of our object. Now don't forget that whenever you are taking your reading, you look directly at the scale. You don't go and place your eye here and then be looking this way. That's going to be wrong. We already talked about this, that is going to lead to a parallax error. So that's how we measure the volume of an object that is irregular. Now how do you measure the volume of a sphere? A sphere is also an example of a regular object. So, and this is how you get the volume. The volume of a sphere is just 4/3 pi multiplied by the cube of the radius. Multiplied by the cube of the radius. So what you just need to get now is to get the radius. So how do you measure the radius of a sphere? A sphere is just like a ball. Like a ball. A sphere is like a ball. So how do you get the radius of the sphere? You can use either your vernier caliper to measure it, or you can use the micrometer screw gauge to measure it. But which one is going to give us a more accurate answer? The micrometer screw gauge will give us a more accurate answer. So we use the micrometer screw gauge to get the radius. But don't forget that the micrometer screw gauge can only measure from here. By the time you place it, you are going to place it this way. You are placing it this way. So this is our main scale, and here we have the vernier scale. So what do you notice from here? You are noticing that the micrometer screw gauge is only taking this value, the value from here to here, which is the diameter of the sphere, not the radius of the sphere. So that means that whatever you get from here, you are not using it directly. What do? You have to convert it to the radius. So you measured the diameter. That's what the micrometer screw gauge can measure. Even if you use vernier caliper, that's what it will still measure. So how do you get the radius? So the radius is just the diameter divided by 2. So whatever you get, you divide this by 2, then you come and use it in this formula. So that's how you are going to get the what? The volume of the sphere. And if you like, you can also use the same method that we use for an irregular object. Throw it inside, you measure the amount of the volume of water in a cylinder, then put the sphere inside so that the volume can increase. Then you measure the new volume and subtract them. You are still going to get the same answer. So now if you have a cylindrical wire, how do you measure the volume? The volume of a cylindrical wire is the same thing as the volume of a cylinder. Let's say this is a cylindrical wire. This is a wire. Now a wire always has the shape of a cylinder, just like it is just that it is very thin, so people do not know that it is a cylinder. But if you look at it very closely, wires usually look like circle on top, then they will now be long below. Just go and check any wire. Now I'm not saying that you should check a wire that has been plugged in. Just check like a wire in a gadget that is no longer working, the one that is saved from electricity. So just check it. You are going to see that it's going to have like a circular top, then a body. So that means that it resembles a cylinder. So now if you zoom it out, this is how a cylinder looks. So a cylinder has a radius and it has a height. Well, in this time around, the height is going to be the length of the wire. That's how long the wire is. That will be the height. Now we said, so this is also a prism, and we said volume of prisms is just the area of the base multiplied by the height. So what's the base? What you have on top is still the same thing that you have below, which is a circle. So what's the area of a circle? That's pi r square multiplied by, what's the height? The height is now the length. So that's how you got this formula, pi r square L. So that's how you get the volume of any wire that you are given, once it is a cylindrical wire. So that's how you are going to get the volume. Now for liquids, if you want to get their volume, it's very easy. You can use a measuring cylinder. Just put them inside the cylinder. You see their volume. You can use a pipette of a fixed volume. The pipettes usually look like this, like a straw with that is fat at the center. Then it's going to have a particular volume here, which is usually 25 cm cube. So the volume of pipette is usually 25 cm cube or 20 cm cube. So that means that any liquid that you take into the pipette, you already know that that will be the volume. So you can also use a volumetric flask, which sometimes usually look, this is a conical flask actually. So but it can also be a volumetric flask. You just put it inside and read the value so that you can know the volume. Now, so how do you measure mass and weight of objects? How do you measure mass and weight of objects? It's quite easy. So for the mass of an object, you measure it with the beam balance or a chemical balance. And these guys, they operate by comparing the unknown mass to standard masses. So this thing is just like, you already know how heavy a bag of cement is. You already know how heavy a bag of cement is. Someone now brought you cement and ask you how many bags of cement is this. Maybe the person have removed it from the bag. By the time you carry it, you'll be able to feel that this is more than one bag, or this is less than a bag, or this is actually one bag, based on the previous experience that you have had. So you just, by comparing the masses, you can know whether it is, you can be able to predict what value that is going to have. So that is exactly how the beam balance and the chemical balance, how they function. So that is how they function. They function by comparing the mass. Any new mass that you bring, they just compare it to the known masses, the standard masses. That's how they are going to compare it and use that to judge what the new mass is actually going to be. But if you want to measure weight, you use the lever balance or you use the spring balance. Now the lever balance and the spring balance, the spring balance operates using Hooke's law. That's what the spring balance used to operate, but we are going to talk about that later. While the lever balance operates with the principle of machines. It operates with the principle of machines, and inshallah we are going to talk about that too later. So how do you measure time? So what is time itself? So time is just the interval of occurrence between events. The interval of occurrence between events. That means you are trying to judge when an event happens and the interval it takes for another one to happen. So the best way we look at time is using before and after. I got here before you. What does that mean? That means I was earlier. That means it took me a shorter time to get here, while it took a longer time to get to that particular point. So that's it. So that's how we use time. That's how we define time. So we measure time in seconds. Majorly, we measure time in seconds. So second is the standard, but you can also have other units. You can have units like hours, days, weeks, months, years, light years, like that. So we have units like minutes, we have hours, we have days, we have years. So those are the other units of time that we have. Now, another important thing that we should know about the other units of time is that there is like a conversion. That is how we used to convert between them. Like if you have 1 year, 1 year is 365 days. That's if it is not a leap year. A leap year contains 366 days. So if you have 1 day, 1 day consists of 24 hours. And if you have 1 hour, an hour consists of 60 minutes. Now, what of a minute? Now, a minute consists of 60 seconds. And that's the farthest you can go. Although you can have like milliseconds and the rest, but these are the common ones that we are supposed to know. So, inshallah, in the next class, we are going to move to dimension. And dimension is a very important aspect of physics, together with everything that we have been doing in our physics. I am giving you a kind of assurance that if you are able to master this aspect of physics, the quantities and dimensions, their units, how to convert from one unit to another unit, you are already like way above a normal physics student, because there are a lot of students that can't do all these stuff, and these are the basics of physics that if you don't know them, you are going to be having problem in the future. So just try to make sure you master everything that we have done in this particular aspect. So the last class for this first chapter of physics is going to end in the next class.